a linear equation given a set of coordinates. So in this example, the coordinates are 210 and 420. But before we go into the actual process of finding the linear equation, let's just go back and revisit the concept or the general equation for a linear equation. So in general, we know that a general linear equation, follows the following rule, which is y equals mx plus c. M represents our gradient. C represents our y-intercept, which I'll just write y for short. And remember, x and y represent our values on the Cartesian plane or within the linear equation. So looking at the general equation and looking at our coordinates, the most logical step to do first would be to find our gradient. And in this instance, I'm going to use the formula m equals y2 minus y1 all on x2 minus x1. So writing my coordinates out again, so for 20, I'm just going to label them which one's x1, which one's y2, etc. So I'm going to say that 2 is x1 and 10 will be y1, therefore making 4x2 and making 20y2. So now substituting these values into the equation, I'm going to have 20 minus 10 on 4 minus 2. So m is equal to 10 on 2, thereby making m5. Now, it's interesting to note that the gradient is positive, and this is going to become more important when we start graphing our equations. For the moment, we'll just take it as it is, and we've just worked out that m is equal to 5. Now, personally, I like to, as I find certain parts of an equation, I like to put them in as I go, just so that, by the end of it, I've got a complete equation. So what I'm going to do now is rewrite the equation having found m. So I'm going to write y equals 5x plus c. So now the second step would be to solve for c. And remember, c is our y-intercept. So this is asking where exactly does this linear equation cut the y-axis. So in order to solve for c, we can substitute a coordinate into what we've now worked out so far, which is y equals 5x plus c. So this is why it's really important to substitute the values that you solved for as you go, because it's going to help you complete the next step. So now that we're solving for c, we can substitute a coordinate into y equals 5x plus c. Let's substitute, for this example, we'll substitute the coordinate 210. So now I've got 10 equals, because remember 10 is y, equals 5 times 2 plus c. Solving for c, we get 10 equals 10 plus c. Solving for c again, I want 10 by itself, so I'm going to make it 10 minus 10 equals c, and c is equal to c is equal to 0. So now that we've done that, we can rewrite the equation. Having found all the elements, we've found c, we've found m. So what we're going to have is y equals 5x plus 0. Now, we generally, if the value of c is 0, we generally write the equation as y equals 5x. So let's move on to an example now where we've been given a graph and we're asked to find the equation of the line shown. So what I recommend doing is if you are given a graph and you're asked to find the equation, actually take the time to look at the graph and the elements that you can see on the graph. For example, we can see that the graph is going in a positive direction, which means that our gradient should be positive. So when we solve for our gradient, we should be looking to get a positive m value. Another thing we can see here is that the graph cuts the x-axis at -2, making that coordinate 2, 0. So I'm just going to write here that that is our x-intercept. Interestingly, we can actually also see where the graph, this particular graph anyway, cuts the y-axis. And it happens to cut the y-axis when y is equal to 10. So just write here y is equal to 10, which means our y-intercept in coordinate form will be 0, 10. So I'm just going to write these coordinates out because they're going to help us to actually find our gradient. So we've got 0, 10. Now remember, when we're finding an equation, the general equation is y equals mx plus c, and c is our y-intercept. Now conveniently for us, this particular graph has shown us what our y-intercept is. It's actually at 10. So instead of finding the gradient first, what we can do is substitute our the c value in, which makes it y equals mx plus 10. Now, what we can do is we can find m, so find our gradient, now that we've done that. Or solve for our gradient. So I'm going to stick with the m equals y2 minus y1 all on x2 minus x1 method. So writing out my coordinates just here. Just going to make that y2 and 0, 10, y1, x1. So substituting my values in now, I'm going to have m is equal to 0 minus 10, and I'm going to have negative 2 minus 0. So m is going to give me negative 10 on negative 2, and when you divide the two negatives, the negatives cancel out and become positive, so it becomes 10 divided by 2, which is 5. So what we've now found is that our gradient is positive because it is 5, which means our graph and our gradient, in theory, what we've solved, is correct. So now, like I said, I like to rewrite my equation as I find out the elements. And remember, before we found our gradient, we worked out that our y-intercept was 10. So therefore, the equation equals y equals 5x plus 10. Now, if you're not confident in finding the y-intercept by looking at the graph, or sometimes the graph might, the y-intercept might be so high up and the graph only shows a certain portion, we can actually solve for our y-intercept by substituting substituting coordinates in. So substituting a coordinate. A coordinate. So let's substitute 0, 10. Now, if we're going to follow the second step, what we're going to write here will be y equals 5x plus c. And this is assuming we haven't solved for c. So now what I'm going to do is substitute x equals 0 and y equals 10 into this equation here. So I'm going to have 10 is equal to 5 times 0 plus c, 10 equals 0 plus c, therefore 10 is equal to c. Now this matches what we found up here and what we saw graphically. So if we're going to rewrite the equation, we'll write y equals 5x plus 10, which is exactly the same as what we worked out by using the y-intercept that we saw from the graph. So just to summarize, with this particular method, it always helps to identify some coordinates by looking at the graph. So take really good care to notice, are there any intercepts? Are there any coordinates that you can read very clearly off the graph? Because if you do so, it's going to help you to identify elements that you need to put together to find the linear equation.